Okay, now we're going to talk about how to transform the reciprocal function. But before we do that, let's do a quick review of the basics of the reciprocal function. So the reciprocal function is a function that is the reciprocal of y equals x. So if y equals x is a function, the reciprocal will be y equals 1 over x. So that's what we're talking about. Y equals 1 over x. That's our parent function. Now the family of these functions look like this when we apply the transformation. So you take that 1 over x, you multiply it by a. Now the a could go up front like this, but what we generally do is we multiply it by the number on top and we just make it a on top. Then the k goes along with the x minus d on the bottom because that's the function. The k and the d are in the function, which is reciprocal on the bottom, and usually they add the c to the c could be put in front also, but usually that's the way we like to write it. Okay, so let's focus first on the parent function and graphing that. So if you remember from our parent function video, we use these key points. So there's the first half of it, and they're in one group, and then here's the other half of it. So if I substitute all these numbers into here and go 1 divided by each of them, I ended up with these outputs. Okay, and if we put those on a graph, we end up with bunched together 3 points in the negatives, -2 over a half up, -1, -1, and -1/2, -2. And on the positive side, we end up with a half over 2 up, 1, 1, 2, 2. And like we said, this thing heads towards the x-axis like this. I'm not doing the best job drawing it, but a curve, a smooth curve that gets closer and closer, but it never touches. If we could zoom in on it, mine's got a little bump there, which isn't great. But if we zoomed in on it, it would never actually touch the x-axis. It would get closer and closer. And same thing here, it heads up. As you enter smaller and smaller numbers, it gets closer and closer to the y-axis, and it heads up forever. On the other side, it does the exact same thing. So it heads down towards the y-axis. So on the left side, it heads towards negative infinity. And on the right side, it heads in the x direction towards negative infinity. And it never touches that x and y axis. So we say for the parent domain and the parent range, x cannot be equal to 0 and y cannot be equal to 0. In other words, it never touches 0. Those are the equations of our asymptotes. So instead of saying x and y can't be equal to 0, the actual asymptotes where they can't touch are x equals 0 and y equals 0. So x equals 0 would be our, or sorry, this would actually be y equals 0, would be our x-axis. Okay, and the other one, x equals 0, would be our y-axis. So I'm a little bit off the axis there. There's x equals 0. So that's a vertical line and a horizontal line. So I'm just drawing over top to illustrate that that's where those two are. So what's the difference between it? When I say domain and range, I'm saying you can't be 0. You can't touch it. So why did I write it equals here? Because these are the lines it can't touch. So these are two lines that we can't touch. So our domain says you can't touch that and you can't touch that. So it's basically I'm writing the same thing, but one's got a slash through it, one doesn't. Because I'm talking about the lines and that fact that it can't touch those lines. Okay? Now, what happens when we transform it? Actually, and just to be clear, right? Remember, what is an asymptote? An asymptote is a line that our graph can't touch. Okay, so that's why our domain and range are not equal to those numbers. It can't equal these. So these two are lines, horizontal and a vertical line. Okay, so now, when we transform it, what's going to happen, and I'll show you. Long story short, because we move this thing up, down, left, right, the asymptotes in our domain and range are affected by the same thing. So what ends up happening is the x values are affected by d, if you remember from our previous videos, right? So it ends up being whatever d is, x cannot be equal to d. No matter what it is, we're going to find as we start graphing these. So on the first one, it might be a little bit apparent. The more we graph and study these in class, the more apparent it'll become. And the y's cannot be equal to c. So it's impossible. So you'll find out as we do this, because we'd end up getting a 0 on the bottom, and then we can't have y equals 0 either. All right, so now that means our transformed horizontal vertical asymptote are just these here. It's x cannot be equal to d means our vertical one, or sorry, now I've just realized I've labeled these wrong, so that's not great. I've put them in the wrong spot. X equals d and y equals c. So now just to be clear, I've noticed that this one is actually the vertical and this one's actually the horizontal. So sorry for the confusion there. Not a great handout I've made here apparently. So again, this would be the vertical and this would be the horizontal. So if you're looking at my video saying something's wrong, you were right. Okay, so let's actually get into graphing one of these, and we'll talk about what we mean. So the secret to drawing these really quickly is this. Knowing this, having this just burnt into your brain and memorized, that these two lines, where are they? Wherever D is, whatever D is, we draw a vertical line, and wherever C is, we draw a horizontal line. And then everything just falls into place there. After we put these 3 points on, we just head towards those lines. So remember that. That's the secret. X equals D and Y equals. Okay, so let's have a look at this. I'm not going to draw the original one again because we just drew it and just talked about it. But what I am going to do is make a table of values somewhere here. Let's just try to squeeze it in down here below maybe. All right, so here's my parent table, right? My parent being y equals 1 over x. All right, and we got those 6 points, right? We have -2, -1, -0.5, and then 0.5, 1, 2. I'm sorry, it's probably pretty tiny on your screen here. And we end up with the outputs. Okay, so let's identify A, K, D, and C. So when we're doing this here, like we said, the family of functions looks like this. Usually we put the A on top, K, X minus D on the bottom, plus C. So our A value is 2, but we got this negative out front. So we have to decide, do we put the negative on top with 2 or do we put it on the bottom? You can do either or, but if you want the quick answer for now, the simplest thing to do is associate that negative like it goes with the top number only. It's only going to be in one place at once. We can put it on the bottom, that's fine, and make the X negative, but then we have to factor it out. So it's probably easiest if we just make the A the -2. So that means we got a negative again, which means we have another vertical stretch. And the 2 means we have that's a vertical reflection. And then the 2 tells us we have a vertical stretch by a factor of 2. All right, so let's make our little table here. And with our stretches and reflections, we're going to take all the y coordinates, and remember we multiply them by a. So -2 times all of them. So all it's going to do is change the signs and multiply them by 2. So this becomes 1, 2, and 4, -4, -2, -1. Now, what is k? Well, normally k would be what's out front of this bracket here if we wrote it like this. But when I do that, there's nothing in front, so it must be an invisible 1. So in this case, k is 1, which is great news for us because that means there's no horizontal reflection to do, and there's no horizontal stretching to do because it's not negative, so there's no reflection, and multiplying by 1 has no effect on it, right? So it doesn't change at all in the x for the x values. So 1 over k times x, right? Well, you say, wait, isn't it 1 over k? 1 over 1, that's just 1, right? So we're just multiplying the x's by 1, which in other words, nothing changes. They stay exactly the same. So that's nice and easy for us there. Now, the last part is the D and the C. So when we're looking at this, the D is on the bottom here. So we got to be careful. It's this guy right here, right? Let me get rid of this. And there's our C. So remember, it's x minus D. So it would really be x minus -3. So D is equal to -3. C is equal to -5. So -3, -5. So what does that mean? This guy causes a horizontal translation. This one causes a vertical translation. Since this is negative, we're going to the left 3. Since this is negative, we're going down 5. All right, so we're going to take all our coordinates before, do what we've been doing in the previous videos, okay, and we're going to transform this thing here. So take our y coordinates, add c, take our x coordinates, add d. So I went 1 times x, which had no effect on it. I'm going to -3 from all of them. So let's start doing that right now. -2 minus 3 is -5, -4, -3.5, and then 0.5 minus 3, -2.5, 1 minus 3, -2, 2 minus 3, -1. And sorry for the tiny table there. It's hard to fit everything on the screen. Let's do the y's now. We're going to take what we did before, which we multiply them by -2. And we're going to subtract 5 from all of them. So 1 minus 5, 2 minus 5, 4 minus 5, -4 minus 5, -2 minus 5, and -1 minus 5. Hopefully I did them all correctly. Maybe you can catch any little quick errors I've made here. Put them in the comments. I'm sure I've made some addition subtraction errors at times. So feel free to point those out for anybody else watching the video. All right, so here we go. I go put those on a graph. The problem is it's not going to make a lot of sense. Remember, they were in groups of 3. So there's these 3. Now, what I would actually suggest is to draw the points after what I'm going to do in a minute. But let's put them on the graph, and then we'll see if we can make sense of it. So -5, -4. Well, that's right there. -4, -3. That's right here. And -3.5, -1 is right here. Okay, so we can see them kind of in a group. Let's look at the next group. -2.5, -9 down, way down here. -2/7 down right here. -1, 6 down right there. So you go, all right, well, I got some points, but what do I do with them, right? This is where the asymptote comes in. Okay, the whole secret to this is, where are my asymptotes? Remember, for the horizontal asymptote, right, that's where y is equal to c. So again, I got these kind of mixed up in order, so maybe we should focus on doing the vertical one first. I have them mixed up like from above. I'll have to change this later so it matches up with our domain and range above. So let's start with the vertical one, actually, make more sense. So the vertical one is x equals d, because we've taken everything and moved it to the left or right. So remember, we moved everything to the left 3. So normally my asymptote was here at 0, right? X equals 0. But now what I've done is I've moved it 3 to the left. So now it's actually sitting right here. Now you normally would use a ruler, but I'll just draw like a ticked line right here. So that right there is now where my asymptote has moved to. So I'm going to erase this. So it's moved to the left 3. So notice now I'm kind of splitting those two into a group, right? So that's this guy. X equals -3. What about our vertical asymptote? Okay, so that one here, I'll do in a different color. Normally, it's right here. Oops, sorry, our horizontal asymptote. I'm mixing them up. Normally it's here at y equals 0, right? But what did we do? We moved all our y coordinates down 5. So I need to move this down 5. 1, 2, 3, 4, 5. So that means it also moves the asymptote down 5. So it's actually down here at y equals -5. So now my asymptotes have moved. Now the x and y axis are still where they're at. Like this is still the x axis. This is still the y axis. The asymptotes have moved. So this is y equals c, or y equals -5. Okay? All right, so now I can see clearly where my graph has to go. So what I can do now is draw a smooth curve that goes through the points and heads towards each asymptote. We want to try not to touch it or cross it. It's supposed to get closer and closer, which is tricky to draw sometimes. Goes off the graph, put an arrow on the end, and it starts heading towards this one and getting closer and closer. Same thing here. Heads towards the asymptotes. Oops, gets closer and closer. That's not a great job. Let's do that again. Closer and closer without touching it. Get as close as you can. And then turns. I got to do a better job going through my points here, and starts heading down off the graph. Put your arrows on the end because it heads off in both directions, and you did it. Now the secret is draw these asymptotes first. The first thing you should do is identify D and C. And the first thing you want to do is draw a vertical line where x equals D. And then draw a horizontal line where y equals C. Do that right off the bat before you do anything else. So when I draw those lines, it'll be really apparent where my points should be. They should be separated. One group on one side and the other group diagonally across from it every time. So draw those lines in first, then draw your points and then head towards them. So now, what about our domain and range? How do I write my transform domain and range? All I say is x can't touch the asymptote, so I just say x can't be equal to -3. And for the range, y can't be equal to -5, right? All I'm saying is it can't touch those lines. So it's a slight difference, right? The actual equations don't have the slash through it because that's where those lines are. But when you do the domain and range, you put a slash through it saying you can't touch those lines. That's all that means. X can't be that, and x can't be -3, y can't be -5. And that's how you do one. All right, so give them a try.